Welcome to Kino 1.4. We recently added Apple Log 2 support to our award-winning video app, Kino. Now, Apple Log 2 is a new video encoding that launched alongside the iPhone 17 Pro. And to understand why this is so exciting, I want to talk a little bit about RAW, log video, and why every camera manufacturer seems to create their own log format. Let's dig in. Every camera is opinionated. And I don't just mean modern smartphone cameras, which use AI and computational photography to try to fix your photos. Even cameras from decades ago make creative choices on your behalf. Consider the following photos that came from the exact same sensor data. Which one of them reflected reality? In real life, you might have seen either version because our perception is constantly shifting based on our surroundings. So for example, if you were viewing this from inside a room with bright, warm lights, you might have seen the first image, whereas if you were viewing it from a dark room and allowed your eyes to adjust, you might have seen the second. That's all to say that modern cameras are not an objective source of truth. A lot of it is subject to interpretation. So let's start with this unambiguous, benign photo and start with the crude sensor data. Why is this image so green? Well, if we zoom in, we see it's actually red, green, and blue pixels living alongside each other, and there are twice as many green pixels as red or blue. That's just a detail about how modern sensors are designed. So the first step is we need to fuse together these three colors, and we run it through a sophisticated algorithm, and we end up with this. No, it didn't appear that blue the day I took that photo. Our brains are constantly adjusting our perception so that grays, blacks, and whites appear neutral depending on our lighting. A camera has to apply an algorithm and make an educated guess, and this is the result. It's getting close, so let's dig into the details. Those clouds appear pure white, like they're blown out. In fact, that information isn't lost, it's still in the file, but our computer screen isn't able to display it. At the same time, the overall image appears a bit flat, and that's because our eyes are used to seeing photos with more contrast. So let's make some tonal adjustments. While I like the final version of this photo, I wouldn't call it correct. There's no right and wrong. The amount of highlight recovery and contrast and choice of palette is all subjective. I could have interpreted the photo like this. This is just a broad overview of some of the steps involved in processing a photo. Like I didn't talk about dead pixel removal or lens corrections. I just wanted to focus on some of the major choices you can make that can yield dramatically different photos. And the most important thing to understand is that when you capture this using a JPEG or HEIC or MP4, you need to commit to these choices at the time you take the photo. These file formats are incredibly difficult to edit later. You can push and pull values, but those files quickly turn to mush. That's because JPEGs, HEICs, and MP4s are designed for viewing, not editing. When your camera takes a JPEG, it throws out most of the information to make that file fast to download and quick to display on screen. So instead, what if we saved all of the information from the sensor at the time of capture? Couldn't you make those changes later? Well, that's a RAW file, and that's all it is. It's a snapshot of all of the sensor data inside an unprocessed, uninterpreted file. The best analogy I've heard is cake. When you're shooting with JPEGs, it's like buying a cake from a store. It's very convenient as long as you like how the cake was made. But if you disagree with the choice, like you're not a fan of raisins, you're going to be miserable trying to pluck them out. When you capture RAW, that's like collecting the ingredients to bake a cake yourself. Now you can make it however you want, but it does require extra work to actually bake the cake. Now for a moment of self-promotion. This is why I made Halide Mark III. It makes developing RAWs as simple as tapping a single button. Mark III is right now available in the App Store in a technical preview. Okay, let's move on. RAW files are more unwieldy than JPEGs. They are larger, so they take longer to download, and they require more processing power to display them on screen due to all those sophisticated algorithms doing the interpretation on demand. At least this used to be a problem decades ago. Modern smartphones are so powerful that you can't even tell the difference between loading a RAW and a JPEG, at least when it comes to still photography. Video is a totally different matter because now you're recording 24, 30, 60 frames per second. That requires fast storage and a lot of it. It's a whole headache. It's really annoying to shoot RAW video. The solution is log video. You could think of a log video as a slightly developed RAW. It still keeps most of the important information, so you still get huge editing latitude, but it's way faster to read and write and uses way less space. Log video performs a number of tricks to save space. For example, it saves the image after it's performed that demosaic step where it combines the red, green, and blue values. That's because you really don't get that many creative choices during demosaic, and it makes it way more efficient to display the video later. The next trick involves taking advantage of how human beings perceive light. This is worth taking a moment to explain. Okay, consider this ramp of color patches. They look evenly distributed. It's going up, say, 10% with each patch. But if you took a light meter and measured the light coming from your screen, it isn't actually a linear relationship. Our eyes respond to light non-linearly. There's a power curve. So while you think it's going one step at a time, it's actually ramping up logarithmically. This is important because cameras see light physically, not based on human perception. This means that when you write a RAW file, which is just a sensor reading, it's going to waste a bunch of bits on details that humans won't even notice. Log video exploits human perception to make the most of the available bits. Before it writes the image data to a file, it applies a logarithmic function to lift the shadows. And this is why if you ever try to play a log video in a player that doesn't know it's playing log, the image appears really, really flat. But once you load that video in a video editor that knows what it's doing, well, then everything appears much more normal. All right, it's still desaturated. That has to do with how the colors are written to a file. We're going to get into that in just a moment. But once we flip some switches in our video editor, we have a neutral image ready for us to apply our creative adjustments. So why did we have to fix the color saturation? Well, that has to do with how log video squashes color. Camera sensors can record a much wider range of colors than you can display on screen. Consider this diagram that represents every color that a human being can perceive. Why does it look like a horseshoe? Okay, well actually this is the real chart. It's a scientific chart with a bunch of numbers and a backstory that I'm not going to get into today. Let's just keep it simple and uncluttered. This triangle covers the range of colors that most computer screens could display for decades. Modern screens can display more colors, not the full spectrum, but due to backward compatibility, often you're limited to the range within this triangle. What happens when you try to display colors outside this range? Well, often you end up with weird-looking results like this blue LED light. Luckily, camera sensors can record outside this range, and in the hands of a skilled colorist, it can smooth out these invalid colors so it looks a little more visually pleasing. So what's the range of colors that your camera can record? In this chart, the dark region falls out of your camera's range, but still, this is a huge upgrade. If you got this far, congratulations, you understand log video, except there's one more quirk. It seems every camera maker comes up with their own log format. Sony has S-Log, Canon has C-Log, and Panasonic, of course, has V-Log, because I guess they didn't get the memo. Do they do this just to lock you into their ecosystems? Actually, no, they all publish white papers that makes it really easy to understand how to read and write these proprietary formats. So why do they do it though? Are they just trying to reinvent the wheel? No. Each camera maker uses a different sensor, so their log format is optimized to the characteristics of that sensor, how it responds to light and different color wavelengths to make the most of the available bits. All right, now we're ready to go on to Apple Log versus Apple Log 2. When Apple launched Apple Log 1 with the iPhone 15 Pro, they only provided a unique log function. That gave you incredible latitude when adjusting exposure and contrast, but they skimped out a bit on color. Instead of providing unique ranges specific to the iPhone, they set everything to HDR television. With Apple Log 2, now they provide the unique range of color specific to iPhone sensors. What does that look like? The first version of Apple Log is slightly flawed. As you can see, part of that triangle falls outside of the range that the camera sensor can capture. That means there are wasted bits. Not only does Apple Log 2 fix this, but it captures more deep blues and purples. Apple Log 2 is definitely a step forward, but it's not going to make a difference in everyday situations. Sure, if you record neon lights or you're recording under blue stage lighting, but this isn't really a feature where you have to go out and buy the latest iPhone Pro. Unless you're shooting a John Wick movie. So Kino now supports Apolog 2, and we took our time with support because we had to do it right. We had to expand the color space where we were doing our math to take advantage of all this extra data. We had to test the different versions of Apolog so different phones didn't process things the wrong way. And we wait a little bit for the third-party ecosystem to catch up. We're now seeing really cool Apolog 2 LUTs like Tyler Stallman's Film Pack, which we used in the production of this video. Kino 1.4 is now available in the App Store. If there's any other topics you want me to talk about, leave a comment and subscribe. Now go out there and shoot some bisexual lighting.